Algebra 1 Common Core, the June 2016 Regents exam. I believe this is video 9 in the series. That I don't know if it's going to end in 9 or maybe there'll be one more for the part 4. We'll see. But we're definitely into the part 3s here. So picking up on 35, there are only 37 questions, so we'll see. Maybe we'll be able to get it all in. Not sure at this point. But number 35. This is kind of an interesting question. It's a very difficult question to do without drawing a very good sketch. So I'm actually going to change the view here a little bit. I'm going to add a blank page and see if I can do a double screen so I can see the question and draw my sketch at the same time. So an airplane leaves New York City and heads towards Los Angeles. As it climbs, the plane gradually increases its speed until it reaches cruising altitude. Now, cruising altitude means it stops climbing up; it just simply goes straight. So it tells us that the plane takes off. So here's the ground at NYC, and it climbs in the air until it reaches it is at a constant speed for several hours after it's a cruise. So it gradually increases its speed until it reaches a cruising altitude, and then it maintains that cruising altitude for several hours. So it climbs, reaches cruising altitude, and then stays on a cruising altitude. After flying for 32 minutes, the plane reaches cruising altitude. So right here, this spot right here, this is 32-minute mark. So 32 minutes after it takes off, we're at a cruising altitude. And after flying for 32 minutes, the plane reaches a cruising altitude and it's flown 192 miles. So it's flown a distance of 192. After flying for a total of 92 minutes, it has flown 762. So for a total, let's say that's here, at a total of 92 minutes, that's not, now the issue here is that's not 92 since it started cruising, that's 92 since takeoff. So that gives you then a total distance of 762 miles. Determine the speed of the plane at cruising altitude. So in order to do speed formulas, a speed formula, we do distance divided by time. So if we want the speed during cruising altitude, that's from here to here, I need to know this distance and its time. Now I already could tell that 32 minutes to 92 minutes, that's a total of 62 minutes. So let's see here, I show my work a couple of spots here. We'll say that 92 minus 32 equals 60. So my speed formula is going to be divided by 60. And the distance, well, since we know the whole distance is 762 to the 92-minute mark, and it was 192 to the 32-minute mark, we need to subtract those. 762 minus 92. I'm going to use my calculator so I don't make any mental mistakes here. 762 minus 192. Sorry, I almost made a mistake there. Minus 192. 762 minus 192. 762 minus 192 is 570. So 762 minus 192. I'm just checking the numbers here. 192. That is so 570. So 570 is the distance traveled during cruising altitude, and it took 60 minutes that they were during that cruising altitude. So when I divide distance divided by time, again, that 570 divided by 60, we get 9.5. And so the speed is 9.5. It never asks for units, these tests, but what we're talking about is these are miles and minutes, right? So 9.5 miles, 9.5 miles per minute. So every minute it flies 9.5 miles. So that's the answer to this first part right here. Now write an equation to represent the number of miles the plane has flown during its cruising altitude. So again, just during cruising altitude, it's going a speed of 9.5 miles a minute. That means the equation y equals, for every minute, it's doing 9.5 miles. So 9.5x. So there's the answer to the first question. There's the answer to the second question. Represent the number of miles the plane flies during cruising altitude only, meaning don't include the 192. So just during cruising altitude only, it's 9.5 miles per minute. So let's not, x, they want you to represent x as minutes. So that's the answer to the second part. Assuming that the plane maintains its speed at cruising altitude, determine the total number of miles the plane has flown 2 hours into the flight. Now, 2 hours into the flight does include the 32 minutes that it was climbing in the air. So it's going this 9.5 speed for not the whole 2 hour time. So how long is it at the 9.5 speed? Well, 2 hours is 60 minutes. And if we subtract the 2 hours is 120 minutes, 60 times 2. I'm really off right now. And we subtract the 92 minutes there, we will get 98. Right? Let's see. The 120 minus the 32 is 88. Yeah, I had a feeling I was doing the mental math wrong. Sorry, I'm not on my game today. So let me erase that. Is 88. Yeah, 92 would be if it were 22. So for 88 minutes, for 32 minutes it did its climb, and then 88 minutes it was at cruising altitude, and that's what encompasses the entire 2 hour flight there. So at 88 minutes, it's doing 9.5 miles per hour. And that's going to give you a total of what? So 88 times 9.5 means at cruising altitude, we're doing a total of 836 plus the, I want to say it was 192, plus the 192 we did while we were climbing. So plus 192. So 836 plus 192 is 1028. So 836 is here. Plus 192 is, again, that number was 1028. And that's the answer to the last part of this question. Okay, so yeah, it's the sketch really helps a lot. And then you really have to kind of think it through and not fall for some of the traps of, forgetting the 192 here or forgetting the 32 minutes in this part. So it's a pretty difficult part 3, I'd say. Took me about 8 minutes to go through it. Kept making mistakes along the way, but we got there. Number 36 is a piecewise question. Let me go back to the, not full screen. Sorry, I want to go back to the single page display and go to 36. And so they ask us to graph these functions below, and how many times do they cross, and how do we know? So let's just graph them. First, we can graph g of x. G of x is just a regular line, 1/2 x plus 1. It's got a slope of 1/2, a y-intercept of 1. So we'll start at 1, and a slope of up 1 over 2. And we go up 1 over 2 until we reach the end, and then we go back to the y-intercept and go the other way. So down 1 over 2. And so we are a consistent rate of change, a consistent slope the entire time. And I'm going to use my line tool to draw a blue line. So I'm writing in blue, not too thick. You should use a ruler or a straight edge to draw the line, arrows on the ends, and label g of x. Okay, f of x is a little bit more complicated because it's a piecewise function. We have two different parts, and -1 is really where the parts change. So I'm going to make a table for f of x. I'm going to actually make two tables for f of x. One for when x is less than or equal to -1, and one for when x is greater than -1. And when it's less than or equal to -1, we're using the 2x plus 1 function. So if we type in, x and y, 2x plus 1. Now I could do that without a calculator because it has You know, it's just a linear function with a consistent slope. But I'll show you how to do this with the calculator because I think that's what most of you probably are going to do for piecewise functions. So in the y equals, we type in that 2x plus 1 function and hit second graph to view our table. And we want to write down everything that's less than or equal to -1. So the highest value we'll do is -1. So -1, -1. And then as these go down by 1, these go down by 2. All right, so if you copy down your table here, let's see, I'll start at, where do we want to start? Let's start at negative 5. -5, -9. Sorry, I have to keep switching back and forth. -5, -9, and then we'll do -4, -3, -2, and -1 because we are going less than or equal to -1. This was -7, -5, -3, -1. And so if you plot those points, okay, I want to erase that little tick mark that I made. -1, -1, and then it's a slope of 2, but we're going down. But this still is a positive slope. And again, we could use our line tool there. This time I'll do it in green. And for piecewise function, where the function changes over, sometimes you have open or closed. Here it's closed. You know, we're doing a closed circle here because we are equal to -1. The next function, I'm going to use the 2 minus x squared function. Now, it says greater than -1, but I do start at -1, but I'm going to do an open circle at whatever this point is because I'm not equal to it. So there is an overlap, but one of them is closed and one of them is open. And I could probably just do this in my head here. 2 minus -1, so I got square -1. Doesn't matter that's negative. Anything square is positive. 1 squared is 1. 2 minus 1 is 1. And I plug in a 0. 2 minus 0 squared is 2. Plug in a 1. 2 minus 1 squared is 1. Plug in a 2. 2 minus 2 squared is 4. 2 minus 4 is -2. Plug in a 3. Ends up being 2 minus 9, -7. Again, you could easily type in 2 minus x squared and see this table here. But I just don't want to run out of time here. So -1, 1 is here, but that's my open circle. 0, 2 is here. 1, 1, 2, -2, 3, -4, -5, -6, -7. And so it'll look like that. I can't use my line tool for the parabola because it's a curve. Arrows on there. This is f of x. Just erase a couple of stray marks. All right, and that's that. Now they're crossing one time here. So how many values of x satisfy f of x equals g of x, meaning how many times do they cross? The answer is 1. And you could just say the graphs intersect only one time. And that's it. So that's 36. I'm past the 13-minute mark, probably because all the mistakes I was making on 35. But that's how we graph a piecewise function and a system like that. There's one more question, the part 4. We'll save it for the last video of the series. See ya.